Assalamualaikum warahmatullahi wabarakatuh. We are from Group 10. We present hydraulic structure, which is breakwater. So, this is our group members, which are NORBATRISYA, WARDINA, NORFATHIHAH, and AINAA INANI.
First, introduction. Breakwaters are often used in constructions that regulate coastal erosion and guarantee secure harbour access. A portion of the wave energy is absorbed, refracted, diffracted, and reflected by these frequently displaced barriers perpendicular to the primary wave direction, lowering the amount of energy that reaches the beach. As a result, wave height is decreased, allowing ships to harbour and reducing erosion. Also, breakwaters regulate the movement of silt across the shoreline within harbour basins, which helps lessen the need for dredging.
So next, we move on to the purpose of structure. The first one is maritime safety and navigation. It is to create calm water areas for safe ship maneuvering and docking. And then to improve efficiency of maritime operation, and lastly for reduce risk of accident and ensure smooth maritime traffic. Next, the second purpose of structure is coastal protection. It is to mitigate wave impact and currents, also to reduce erosion and protect coastal infrastructure, and lastly to maintain stability of beaches, ports, and coastal structures. Moreover, the purpose structure of breakwater is environmental conservation. It is to create habitats for marine life, also to promote biodiversity and support coastal ecosystem, and lastly to act as an artificial reef, enhancing marine biodiversity. Lastly, for the purpose structure of breakwater is coastal defense and resilience. It is to protect against storm surge, tsunami, and sea level rise, and then to ensure long-term resilience of coastal communities and infrastructure, and lastly for promote sustainable development and use of coastal resources.
Design of breakwaters. Breakwaters are essential structures in coastal engineering designed to protect shorelines and harbors from the impact of waves. They come in various types, each suited to specific environmental and functional needs. One of the types of breakwaters is mound breakwater. Mound breakwater is a collection of undressed stone blocks and natural rubble that is frequently augmented with man-made, extremely heavy blocks. So the entire assembly is deposited without consideration for bond or bedding. This is the simplest type and is constructed by pitching or dumping rubble stones into the sea till the heap or mound emerges out of the water, the mound being composited and the action of wave regulates its side slopes. The quantity of rubble depends upon the depth and height of tides or wave. The wave gradually drags down the mound on exposed sides, giving it a flat slope on the sea face. Such flattening must be protected as far as possible. The picture illustrates a typical rubble mound breakwater design. A sediment core, a geotextile, one or more granular, underlayers and armor layer made of rock or concrete armor units, and a two structure make up the fundamental structure. These parts serve the following purposes. First, geotextile. Geotextile is blocks the passage of sediment particles, preventing erosion of the seabed and core by allowing pore water to pass through. During installation, great care must be taken to prevent damage to the filter material. Throughout the structure's lifetime, the geotextile's filtering ability must be maintained. Next, granular underlayer. Granular underlayer protects the geotextile against puncturing by the overlying armor elements. It softens hydraulic pressure gradients, reduces the forces on the armor elements, and provides interlocking for the armor layer core. The recommended layer thickness is at least 60 cm, about 1.97 feet, and the granular size 10 until 20 cm, about 7.87 inches. Next, armor layer. Armor layer protects the underlayer or core against damage by wave action. The last one is two. Two prevents sliding of the armor elements along the slope of the structure, increases the geotechnical stability against microscopic failure, and prevents undermining of the structure due to scoring. So breakwaters fall into two primary categories based on whether their construction permits with overtopping or not. The decision between an overtopping and non-overtopping rubble mound structure is largely influenced by the intended use of the space immediately leeward of the mound breakwater.
A breakwater's basic purpose is to shield the shoreline from the strong wave action. It does this by lowering the tidal energy as it hits the structure and gets reflected off. The waters lying behind this breakwater structure are notably calmer and better protected from the tidal currents. Breakwaters can be categorized as coast protection or harbor protection structure or both. As navigational aids, breakwaters make the sea calm enough to permit the safe use of harbor amenities and marine operation. On a smaller scale, a breakwater might simply be built to safeguard a recreational beach or small docking facility from strong wave. It can also be used to encourage sand build-up in a protected beach to control coastline erosion.
The example of famous place of breakwater structure is in Palm Jumeirah Breakwater in Dubai, United Arab Emirates. The man-made Palm Jumeirah offshore islands in Dubai, United Arab Emirates are home to upscale hotels and private homes. The archipelago looks like a stylish palm tree enclosed in a circle when viewed from above.
That's all from us. Thank you.